Good morning, everybody. It's great to see you all here to help us launch this new Saturday morning physics season, and we're really excited today. I'm physics professor Tim Chupp, and I work with the Saturday morning physics team of many people, including Professor Rachel Goldman, Carol Raybook, and Monica Wood. I just wanted you to know that there will be a question and answer period at the end of today's presentation, and for those of you online, or even those of you here, you can send questions to physics@umich.edu, and also we will have the opportunity for you to ask questions yourselves live here in the auditorium. So now it's my pleasure to introduce the chair of the physics department, Professor of Astronomy and Physics, David Gerdes.
Good morning, everybody, and welcome to those of you here in the room, and also welcome to our audience who's joining us online. It's really my great pleasure to welcome you here to Saturday Morning Physics. Can I see a show of hands among our audience? How many of you attended Josh's event last January live from the space station? Lots of hands. And how many of you are attending Saturday Morning Physics for the first time? Wonderful. I'm so pleased to see you all. The most important guests in our audience today are all the young people who will be inspired by Josh's story and career to maybe go on and do great things yourself, and I'm so glad you're all here. Welcome on behalf of the whole physics department. I'd also like to welcome the Dean of the College of LS&A, Ann Curzan, who's joining us today. Thank you for supporting us. And I especially want to thank those people who choose to support us financially. This is a labor of love for us, but it also costs money to put on events like this, and I'm so grateful for those of you who have given, large or small. It all makes a difference, and I know many of you are here in this room, and I'm really grateful and appreciative of your support. Saturday Morning Physics has been a tradition in our community for over 25 years, and it continues to thrive thanks to the hard work of people like Tim and Rachel, who are organizing it, Carol, who's in charge of marketing and publicity, Monica Wood and her demo lab team, and all the AV and media and technology support people who help make this great presentation accessible to as many people as possible. So thank you for working hard for us on your Saturday. Today, it's our pleasure to welcome NASA astronaut and Ph.D. physicist Josh Cassada back to Saturday Morning Physics, back to the University of Michigan, and actually back to planet Earth. Josh grew up in Minnesota and got his undergraduate degree in physics at Albion College, just up the road west of Jackson. He then went on to the University of Rochester and earned his Ph.D. in experimental high-energy physics, where he worked on the collider detector at Fermilab experiment alongside many of us here at Michigan, studying the world's heaviest elementary particle, the top quark. So far, that's a pretty standard physics biography of someone we might introduce at Saturday Morning Physics, but that's where Josh's world line starts to deviate from what most PhD physicists go on to do. Upon completing his PhD, he commissioned as a naval officer, became a test pilot, and a flight instructor. He's logged over 4,000 hours of flight time in over 45 different aircraft, including flying 23 combat missions. In 2013, he was accepted into the Astronaut program, and almost exactly a year ago, on October 5th, 2022, he piloted a SpaceX Crew Dragon spacecraft to the International Space Station, where he and the other members of his crew spent 157 days in Earth orbit. During that time, he conducted 3 spacewalks and delivered 1 Saturday Morning Physics talk. Josh, we're so happy that you have returned safely to Earth and are joining us here again today. Please welcome Josh Cassada.
Thank you so much. Good morning. It is so exciting to be back here and getting a chance to do over what we did the first time. I'll tell you what, that was such an enjoyable conversation to have from the space station. There were just a couple downsides to it. First of all, I was kind of trapped. I was, for those of you who were there or saw it online, I was floating, but I was kind of stuck in that module because the camera that we use is cabled into the space station. And so I so badly wanted to grab that camera and show you around the space station, show you some of the different experiments that we're running, show you some of the different modules, show you how we go in and out of the space station when we're doing spacewalks, show you the robotic arm, show you that incredible observatory that's usually on the Earth-facing side of the space station where we get some of the most incredible views. But I couldn't do it. So the upside is that I can show you that today. We've got a really cool video that NASA put together that's kind of a summary of our mission. And yeah, we were on board for about 5.5 months. So what I'd like to do is also just kind of give you a feel for the space station before we get into that video. And then we'll talk a little bit more about the future after that. The other downside to the last Saturday Morning Physics, which again was, I think, halfway through our mission, it was about 9 months ago, was that, if you remember, I was informed that you had donuts. And I'm going to tell you, that's a pretty tough thing to hear when you're in space and stuck there. So I got 0 last time. I'm planning on at least 2 today. And in fact, Professor Chupp told me during our last conversation that he would save one for me. He did. It's frozen. I don't want it. So if anybody wants it, you can have it. So this is one of the spacewalks that we did. Our crew did a total of 5. My buddy Frank and I, we did 3. And all 5 of them were really focused on upgrading the electrical generation of the space station. So this is a super fun picture that was sent to me. It was in my email inbox when I got back in that day. And I love being able to share this entire mission with anybody who wants to listen. It's just an incredible thing to be a part of. But it's also super fun for me to be able to see this mission through the lens of my friends and my family and my colleagues, the people who actually made it possible for me to get to space. So after this spacewalk, my advisor from grad school, Paul Tipton, a well-known high-energy physicist and colleague and friend of some of the people here in this room, he posted to social media this picture along with this quote: "For those of you who doubt the benefits of a graduate degree in physics, I'd like to point out that one of my former students just got a really nice job installing solar panels." And he's absolutely right. I'm a government employee, so the pay is probably just about the same. But it's super fun to be able to do the hard work, but also be able to enjoy it and just get as much out of it as we can as a society. I'm never not blown away when I see the things that we can accomplish as a society when we're all on the same page. And spaceflight is certainly a great example of that. Tens of thousands of people make this happen. We just happen to be the people up there executing the plan. So with that, I want to start with this photo. This is a photo that I have mixed emotions about. We took this photo probably about 3 weeks after that first Saturday Morning Physics. I love this photo in that, you can see here, this is the Legacy solar array. That's one of the, we have 8 of them, but this is one of the original ones. And here's one that we actually installed ourselves, and the planet is just so beautiful at night. You'll see some video of lightning at night. It's just captivating. I love the aurora, of course. It's just spectacular. One, it's gorgeous, and 2, it's quantum mechanics. You're seeing it happen, so it's really fun. The reason I feel a little guilty about this picture is we took it on a Tuesday morning. Mission Control had worked us through the weekend, and so they gave us half a day off on a Tuesday, which just never happens. So Koichi and Nicole and I, we headed down to the cupola, and we set up all these blackout curtains, and we got the exposure right, and we did this really cool time lapse that you'll see in a bit. But the problem is, the reason we knew to do that on Tuesday is because on Monday morning, I'd woken up pretty early, and I had floated down to the module where the toilet is, but it's also where this cupola is, this observatory. And I float in there, and it is pitch black. And we usually leave at least one light on, at least in the dim setting, so you can navigate and figure out where you're headed. And so I float in there, and I said, "Hey, is there somebody in here?" And I hear Nicole down in the cupola, and she says, "You have to see this." And so we spent the next 30 minutes just immersed in the most remarkable aurora that somehow is better than this. And I can't even put it into words. It was just overwhelming. And so that as soon as we had an opportunity, we grabbed a photo of it. And so that's why I love this photo, and also at the same time, I'm sorry. But what I like about this photo as well is it shows you just how close we are to the surface of the planet when we're in low Earth orbit. We're only 250 nautical miles off the surface of the planet. That's essentially from here in Ann Arbor, straight line up to the Mackinac Bridge, just past the Mackinac Bridge, into the UP, not quite to Lake Superior. So if you took that distance and pointed it straight up, that's all the further we are off the surface of the planet. And so, so I thought before we get into the video, we would talk a little bit about what orbit is and how you get into orbit. So my 12-year-old and I, we took apart one of these Nerf guns, and we got in there, and I took out the spring, and I weakened it. I cut off about a third of it, which absolutely does not score you any dad points at all. But you'll see, if I fire this, let me step over here. If I fire this bullet horizontally, it's probably going to come out at 15, maybe 20 miles an hour. Nobody's surprised, right? Made it, 30 feet. This one, Graham wouldn't let me touch. So this is the original. Cindy, I promise not to hit you. But this one's probably going to come out about 5 times the speed. But again, nobody's super surprised, right? It traveled further before impacting the ground. Well, if I was able to take this apart and put in a stronger spring, one that would launch that bullet a little over 17,500 miles an hour, one, I would score back all those dad points and then a whole bunch. But what would happen is that bullet would come out so fast that as it's falling towards the Earth, the curvature of the Earth is bending away from it. And that is what orbit is. We would be in an orbit of about 5 feet of altitude. Now, of course, that doesn't really work, right, due to air resistance and due to things that are taller than me, right? But that is what being in orbit is. And this was the idea that Sir Isaac Newton had. It was called, well, we call it now, Newton's cannon. And here's the idea. We fire a cannon horizontally, and it's going to impact the Earth. We fire it a little faster, and it's going to go a little further before it impacts the Earth. And if we fire it fast enough, it's going to keep falling towards the Earth, but the Earth is going to bend away from it. That's what orbit is. And so that's what we've been doing on the International Space Station for almost 25 years. We've just been falling towards the Earth. Now, there are just enough molecules up there at that altitude that the space station tends to drag down just a little bit. So we have to do what's called a reboost, where we fire some engines on the back of the space station every couple months and just kind of boost the space station back up just a couple kilometers. Sometimes we use that whole maneuver to avoid debris that we can see that's coming. And, you know, Newtonian mechanics is great. You can see, hey, in a month and a half, this object's going to be a problem, so let's plan our reboost accordingly. I bring that up because in the video, you're going to see what my friend Anya and I did when we were probably supposed to be working during a reboost. We knew one was coming, so we stopped working at that moment, and you'll see what we did. One thing back on the bullets here, another thing you're going to see in the video is we did a World Series promo because we were up there in October, of course, and you know, everyone's trying to get their lines right, and because I pitched in baseball growing up, I was assigned the duty of throwing the baseball at the camera. Koichi will catch it, and he'll say play ball, and that's the commercial. Inevitably, somebody's going to mess up their line. You're going to have to do another take. But I will say I was responsible for at least 4 of them, simply because my brain couldn't erase this whole falling towards the floor problem. Every time I threw it, no matter what speed, it would go high. It would go 2 to 3 feet. Now, we'd been on orbit 3 weeks, so I probably should have had it figured out by then, but I could not stop throwing it high. So you'll see, I'm kind of embarrassed, when you see this commercial, you're going to see that I fired in really fast, because that's the only way my brain says that's how it's going to get there. So in the video after that, you're going to see that Koichi does it exactly right, and he just floats it, and it's super cool. So, and for completeness, of course, in this Newton's cannon example, if you fire it even faster, now you're going to go somewhere really exciting. Hopefully you did it on purpose. But you're headed to the moon, you're headed to deep space. And that's in fact what NASA's doing in the next year and a half, and we'll talk about that briefly next. Okay, so this is the International Space Station. That's where we are. We're in low Earth orbit, about 250 miles off the surface. We're doing that 17,500 miles an hour. That seems really fast because that's relative to where we are right now. But in actuality, you're going to see in the video, when we come into dock, nothing fast happens in space, which is exactly the way you want it. We're coming in also pretty close to 17,500 miles an hour, but with just a little extra, about 8 centimeters a second, and we dock. So this is the International Space Station. It is about the size of a football field from one end of the solar arrays to the next, to the far end. It's about the size of a football field that doesn't also include 107,000 seats, right? But we can't live, whoops, that wasn't what I meant to do. We can't live in any part except for the central location. Those are the modules. That's the pressurized section. So if you can imagine these modules plugged together, kind of like Legos, it's about the volume of a 6-bedroom house. The cool thing about this house is that you can use the floor, you can use the ceiling, you can use the walls. There's no space that goes wasted because you don't need to use it. And we can talk a little bit about how you sleep in space, but to be honest, your brain has no idea which way is up, so it just gets really comfortable very quickly. You try really hard not to fall asleep at work. So the International Space Station, because it's traveling so fast, we go around the planet every 90 minutes. That means we see 16 sunrises and sunsets every single day. So that is why we have these solar arrays. We are charging the batteries of the space station for 45 minutes, essentially. And then when we're in eclipse, when it's dark, we're going to run off of those batteries for 45 minutes. And then we're going to start charging again. And we just repeat that process for 25 years. It's a pretty remarkable system. These solar arrays are getting older, so we were able to go out there and upgrade them, and we actually installed some new ones, some really cool technology that we'll be able to talk about. But the whole purpose of the space station, in my mind, it's twofold. For me, primarily, this is where we get good at long-duration spaceflight. There's nowhere else you can develop the technology, the operations, the hardware, to be able to take our society to deep space. Because if we have a problem on the space station, worst case scenario is we can get off the space station, we can be back on Earth in a handful of hours, 4 to 6 hours if we really needed to. And there are a handful of emergencies that we would respond that way, and so we're thoroughly trained on that. We actually had one that got us in that kind of situation, all strapped into our spacecraft, and then after that happens, I had been working out at the time, so I'm in sweaty clothes and shorts and sneakers, and I'm all strapped in, and then you realize, oh, wait, this isn't training, this is the real thing, and I'm probably going to go home dressed like this. Turns out it wasn't a problem. We were okay. But it's also this national laboratory, and at any time, we've got 200 to 400 different experiments being run inside and sometimes outside of the space station. In the video, you're going to see examples of things like material science. One of the experiments we worked on up there was developing a new class of high-performance alloys. This can be used for new coatings and gears. And the idea is these alloys are made of materials that are vastly different in terms of density. And that makes it a real challenge to make those alloys here on Earth. On orbit, you're not fighting gravity, so that kind of production is accessible. You're also going to see things like something called the Plant Habitat Facility. You're going to see these tiny little plants. They are the plant world's equivalent of fruit flies, Arabidopsis. Is that right? Any biologists in the room? Do I have that right? But anyway, these are plants that are quickly going from generation to generation. And it turns out that in spaceflight, that environment actually changes the DNA of the plant. And so the question that the researchers are looking into is how and if those changes, those epigenetics, are passed on to the next generation, maybe when that plant isn't even in the spaceflight environment anymore. You're also going to see the fact that we were growing dwarf tomatoes in space. We varied things like the soil and the light in terms of its frequency or its duration. And you know, this is obviously something that's going to be really important to deep space exploration. Nobody wants to be Mark Watney eating just potatoes for 2 years, right? You're going to see that we are the subject often of the experiments. You're also going to see things like there's a 3D printer that I got to install when I was on board. About a couple months before launch, our boys and I had a chance and we built a 3D printer. And it was super fun. But if you've ever used a 3D printer on Earth, if you have a kind of a strange structure, you have to build some supports in there so that the whole thing doesn't come toppling down. And then when it dries, you can break those supports off. In space, you don't have to do that. And so what's really cool is this 3D printer that you're going to see, we print with biological cells. So the idea is to eventually be able to print entire organs from a patient's cells. It's just absolutely remarkable. We'll also see some more fundamental physics experiments. You'll also see what happens when astronauts have a weekend off, and we find some stuff to play with. And then, so that's kind of the science section. You know, it's going to go fairly fast. I'll briefly hit on some of those things, but I just wanted to mention it now while we have a little bit of time. So with that, I hope I've just kind of laid the groundwork for what the International Space Station is and what we're doing there. If you don't mind, Michael, I think this is a great time to start that video. It's about 25 minutes or so. There are parts of it that I'll be able to narrate and talk over, and then there's parts where, you know, the professionals who do the talking, you're going to want to hear them over me. This part's a little cringy because it's about me, soon it won't be.
And there they are. The astronauts of Crew 5 taking their first steps outside as they head to the pad. There they go. The rocket recline. There it is.
I like the way they did it kind of in coordination, getting ready to kind of take that next step and head into the vehicle.
And there
So
you
we have
see
a chance
the
to call our
astronauts
families here.
doing just that.
It looks dramatic.
Just
looking
right
at a
there,
helicopter.
looking out
Waiting for my
over
turn to use the phone.
Launch Complex 39A and the Space Coast. No doubt having a view that is similar to this. From our flight ops team here at Kennedy, what a great shot. And here we go, the first two astronauts to board Crew Dragon. On the left, Josh Cassada, and on the right, Commander Nicole Mann. And here come our second two astronauts, mission specialists Koichi Wakata and Anna Kikina.
Special thanks on behalf of all the crew to our family and friends. It is your love and support that help make dreams come true. Now let's do this. Crew 5 displays are configured for launch.
3, 2, 1, ignition, engines full power, and liftoff.
Stage 2 Alpha.
Stage separation confirmed. Copy 2 Alpha.
And there is separation.
Dragon separation confirmed.
Call this little guy our free fall indicator. We're here to tell you there's plenty of gravity up here. In fact, that's what's keeping us in orbit right now and preventing this trip on a Crew Dragon from being a one-way trip.
The moon in the farthest portion of your screen there, the furthest back circle, Dragon in the middle, and the International Space Station in the closest field of view, of course, with our pale blue dot underneath.
It was amazing that Kennedy Space Center was able to pull that off. Hurricane Ian had come through just a couple days prior, so that's why there was all that water next to the launch pad. Absolutely amazing.
on the big loop, contact and soft capture complete. Attenuation in progress.
Here we come through. First one through the hatch is going to be Nicole Mann, commander of Dragon. Next one through the hatch is Josh Cassada, the pilot of Dragon. Koichi Wakata of JAXA coming through the hatch. And last but not least, Anna Kikina of Roscosmos just entered the International Space Station, and Crew 5 is officially ingressed from Dragon Endurance into their home for the next 6 months, the International Space Station.
So here's that material science laboratory that we were talking about. This is the actual experiment. You can see I was having a little trouble finding the camera to give the ground my thumbs up. And this is where we're doing those development of those new class of alloys. Absolutely remarkable that we can leverage the fact that we're in free fall. This is that plant habitat, looking at the changes in the DNA and how that's passed on from generation to generation.
And Josh, that was some fantastic video and great KFT work there.
So these are those dwarf tomatoes. They took a lot of care and feeding every single day in there, and varying the amount of water. You can see the different light. There's an example of being used as an experiment myself. This is a European experiment that's looking at the differences in an astronaut's perception of mass and motion. It's also a great place to strap yourself down to get a haircut on the weekends. This is that 3D printer that we were talking about. We've printed human knee meniscuses with it. And in fact, we were supposed to print with cardiac cells while we were on board. Unfortunately, those cells didn't make it to orbit, or at least they didn't make it alive. There was a problem with the cargo vehicle, and I'll show you that. This is the alpha magnetic spectrometer. This one has some Michigan ties. It was initially proposed by and still led by Michigan grad and Nobel laureate Professor Sam Ting. The idea is that this detector sits on top of the space station and is continuously sifting through cosmic rays, looking for signatures of dark matter and also sources of antimatter in the universe. I remember when Professor Ting came to Fermilab when I was a grad student, and he was giving us a brief on this experiment, and he said astronauts will never need to touch it. And I remember leaning to my advisor and saying, I really hope he does it. I really hope it breaks, because I really want to fix it. Turns out a great friend of mine, Drew Morgan, did exactly that. He was able to upgrade the cooling system on the alpha magnetic spectrometer with his crewmate. This is the Cold Atom Lab, another really cool experiment. The researchers refer to it as the coldest spot in the universe. So what we're doing is we're making a Bose-Einstein condensate. What that means is we're just taking a cloud of atoms and we're cooling them down almost to absolute zero. And so we use the same technology we do here on Earth, and so those atoms, those individual atoms, actually start to behave as one. One of the great examples or analogies that I've been given is like dancers in a chorus line, all kind of doing the same thing. The neat thing about doing this in space is you don't have to inject a lot of energy in the system to initially suspend those atoms, and then when you release them, their dwell time, they exist a lot longer before hitting the sides of the container. So that, on Earth, when that final release happens, it just falls to the bottom. We found a Teflon hoop in one of the bags, so I grabbed it and charged it up with some yarn. That's just a drop of water. I am certain we had no idea the audio was being recorded. We were just so excited that we pulled it off on a Saturday.
We're in the middle of a reboost right now. The jets are back there, they're firing this way. And I'm gonna keep accelerating towards the Russian segment. Oh, this is so cool. Wait to my friend Anya. He was holding on to the... Oh, here we go. Oh, it works. F equals MA and the speed is picking up. physics. There's so much stuff. Oh, that's so cool. Physics is awesome.
So the space station is moving around me at that moment, which is just so fun. I feel bad that we can't.
There it is. What's us? Got him. I have you loud and clear, and I'm ready for questions. Over.
Gabriel from Cayman Islands. What do you do in space? Over.
Hello, Gabriel from the Cayman Islands. Well, I'll tell you, every day is different up here. Some days we're doing research and helping run those experiments that we were just talking about, and those experiments go from everything from biology to physics to research on the human body. Or sometimes we're doing maintenance on the space station. And sometimes we have to do even more adventurous things like go outside and do a spacewalk.
We have a loss of signal.
Ladies and gentlemen, we just shared a moment in history.
Ciao, ciao.
Thank you. Bye.
So fun to do ham radio events with children around the planet. It was really cool. These are the first couple of spacewalks that Frank and I did. This one, we're going out to set up the spot where we're going to plug a solar array into on a next spacewalk.
Ready, Frank? Yes, sir. Here it comes.
We had to turn the space station around the night before, so I got a call from the flight director who let me know that, but I'll tell you, when I opened up that hatch, I knew it was coming. I still wasn't okay with the Earth going the wrong direction.
Woohoo! That looks great, Josh.
Thank you.
That thing was a bear to get
heavy and
off.
light at the same time.
It had been on there for 23 years, so my job was to get it off.
You are completely clear from the side. So, safe travels. Thank you.
So this is
Half meters to go.
Copy. Say it again. How many meters?
It's incredible.
2.5 meters to go.
Copy.
This thing will roll out. You'll hear the term IROSA. It's a roll-out solar array is what that stands for. And so we need to get it over to its spot. We need to plug it in. We need to unfold it, and then we need to unfurl it. And it is the coolest bit of tech. So the spacewalk before this, you build the...
You are clear of the IROSA, but I don't think you realize how close we are. We're only 3 feet away from each other when you swing. Oh, really? Yeah. Thank you for letting me know. Oh, no problem. It's not an issue.
It's a lot of work to position it.
The top left, you can see some of the bolts sticking out. Those are going to be the hard capture. Those two handles you see are going to be our soft capture mechanism. So crew just working on aligning IROSA, getting it in place.
I understand this looks aligned. It looks great. Can you watch your helmet? There we go. Nice. Is it in? Yep. Well, Nick, I think we got 2.
We were all watching. Nice work.
When you can make a flight director
See the motion.
it feels good.
Copy. We see the release and deployment.
Second bolt release. IROSA now deploying.
That's
amazing job from the engineers who came up with this idea. The ones who put together the plan. This is remarkable.
In one of the smooth operations seen in recent spacewalking history by Cassada and Rubio. And the electrical systems officer here in Mission Control reported a short time ago that the newly installed IROSA is generating perfect electrical output.
That was a great sentence to hear.
Hi, Frank.
Long day.
Good. Think you might hold a new record for most turns on a Ph.D. in a single day. Hey, that's great. Oh. Nicely done, dude.
Hey, for Frank, Josh, and Koichi, Duke, I just want to say that this is the kind of day that makes you want to clap your hands and to the station. We bring new power, more power generation restored on this EVA than ever. So let MTC be heard to the ISS. Let there be light. Great job. Come on in.
Wow, that is overwhelming. You guys are incredible. Thank you.
That was pretty overwhelming. You're not supposed to cry in a spacesuit, so we're going to call it allergies. But that was really fun to be a part of that team. And then it was Koichi and Nicole's turn to go out the door. They're doing something similar. They're not installing the solar array, but again, they're building that apparatus that the solar array will plug into. So we've installed several of these, and it's pretty remarkable that we are...
Koichi, you are go to egress the airlock. Once you've egressed, turn on your HECA.
We're able to continue to improve things that are as massive as solar.
Getting high definition views. This is Nicole Mann, call sign Duke. She's wearing the suit with no stripes, and she's got that giant bag with her. That's the strut bag that has the mounting platform that they're going to be installing today.
So that
this
bag
view
on her hip
of Duke's helmet
is used
camera,
to build this triangle,
clearly see
and that
the
triangle
full
then
build of the upper
gets
triangle.
attached
They
to the
put
space station.
two
and
of
then
the
we
three
attach a solar array
sections
to
of
that
the triangle together. Now, the two of them working together to install the final part of that.
I felt bad that the bag was twice the size of Nicole. She put it exactly where it needed to be. It was amazing.
Looks like Koichi Wakata, an astronaut from Japan, is the first out of the hatch.
Spacewalks are a lot of work. They're a lot of work inside, too.
1.240.
Of course, you can't dress yourself. And
NASA astronaut Josh Cassada, you see there in the hat in the lower left corner of your screen with NASA astronaut Frank Rubio in the short sleeves in the upper right, working now with spacewalker Koichi Wakata, getting his safer unit off, getting his helmet off. We're going to get his gloves off as well.
The Safer's jetpack.
Just like they did with Koichi Wakata, our suit IVs Frank Rubio and Josh Cassada are working on either side of our spacewalker, working to remove the safer units, the simplified aid for EVA rescue.
Hopefully you never need to use it. It would be if you had fallen off the space.
And the gloves are off as our suit IVs, NASA astronaut Frank Rubio and Josh Cassada, work to get our spacewalkers out of their spacesuits right now. Of course, having some playful pictures taken along the way.
So when the Russians were on their way out the door to do their own spacewalk, we were woken up during the middle of the night. Turns out the Russian Soyuz...
In their Orlan spacesuits, Russian managers informed them that the spacewalk tonight would be canceled while they evaluate the next course of action in determining what may have caused the leak in the Soyuz vehicle.
So their vehicle to get home was no longer safe. It lost all its cooling fluid. So it was a pretty amazing solution to work with SpaceX, work with NASA, and we actually got into the SpaceX vehicle, our SpaceX vehicle, removed some struts, and found a way to get Frank's seat in there in the case of an emergency so we could get him home safely. One of my favorite things, it's probably not surprising, is when things break on the space station. We get to do maintenance. This is actually an upgrade that Nicole and Koichi were working on.
Good to be back, Koichi, and thank you very much, Duke, for all of your hard work today. Copy thumbs up and copy wave.
But that's next generation
Very good. For your heads
carbon
up,
dioxide scrubbing.
Our hope today is to make it through step 48 to have all screws
so we can test that on orbit.
Would be our best hope for today.
This is something we were never supposed to
Houston
do.
Station on 2 for airlock. We're at 19.3 and 19.4, and we haven't seen anything off nominal yet.
The first spacesuit that I put on, the fan wouldn't turn on. And so this was never designed to be worked on in space. When we had a space shuttle, we could bring it home. The experts would work on it. So they eventually got comfortable letting Duke and I do some open shoulder surgery. And it was a pretty challenging day, but it was super fun. That spacesuit works, and in fact, Nicole took it out about maybe a month later. And that's just another install of a different laboratory. That's a science glove box where we do a variety of different experiments. One of the hardest parts about living in space is being human and being in space. Right now we're burning calories just by sitting here. We're stressing our bones. In space, you're incredibly lazy. You don't have to do much. So we work out 2.5 hours a day because we don't do anything the other 21 and a half, really. Here's Frank. You can see that bike. It's really hard. That bike is a challenge. The treadmill really isn't. I'll talk to you about that later if you want. This one we perfected at the Saturday Morning Physics, and then we were told we're not supposed to use the drill for that, so we got one more really good video. A little conservation of linear momentum. Frank was not supposed to launch it that fast. Here's conservation of angular momentum. They were not supposed to spin me this fast. and we end up hitting the GoPro. It's a mess.
Greetings, baseball fans!
We're looking forward to watching a great World Series up here.
Play ball! Had he not caught that, I think we probably wouldn't have done Saturday Morning Physics because I would have shattered that camera. Again, this is a Saturday that we had off. We didn't get any of this approved, but we found some Alka-Seltzer and some food coloring. It's just water, and it's just amazing. It ends up looking like one of those slushies when you add all the colors. Nicole regretted this decision. We don't have a shower, so that makes life pretty complicated. I did figure out that you can kind of have your own mobile jacuzzi due to surface tension of water. I could just squirt some warm water on my back and then shake my body, and it would just kind of move around where I needed it. We were up there for Christmas. I actually got to read, it was the night before Christmas.
With the traditional pepperoni pizza for
this is Christmas Eve.
Sergey, you're gonna want a napkin. Oh, here we go.
We developed a method for making pizza. It was incredible.
That's so great. Oh man.
Anya does everything with intensity. So we figured out we could see the cupola. This again is the Earth-facing cupola, but we could see it from the Russian segment of the space station. So that's how we were able to get that image of us hanging out in the cupola from a different part. When you're doing crunches, when you're working out, that is the view you have, is out that cupola. So there's a lot of incentive to do that next rep. It's gorgeous. This is the time lapse that I was talking about. You can see how the solar arrays are tracking the sun. That's the robotic arm there in the way. You can also see our Crew Dragon, just the fin there. I don't remember ever floating down there and not being absolutely amazed. It's just the most incredible planet. Never gets old.
Engine ignition.
We do need to resupply the space station with hardware, with food. We don't actually fly water all that often. I'm not sure if you know why we don't need to fly water anymore. But the joke is we turn yesterday's coffee into tomorrow's coffee. So we're able to reclaim all the water. So we don't have to launch quite as much water. This is how we captured that vehicle. This is, you can see that solar array never fully deployed. And so we lost half the power on that cargo vehicle, which included those cardiac cells for that biofabrication.
I agree with her. That from Leo. The stars do not look bigger, but they certainly look brighter. Huge congratulations to the NG-18 team for their tireless efforts in getting Saturday to the ISS and for a successful capture event.
Continuing to get HD views of Dragon as it approaches the International Space Station.
Copy, we're monitoring in steps 5 and 6, and we see approach to docking port mode, range decreasing, and block Bravo looks good.
Great work down there today. We're excited to unpack and get to work.
That's the vehicle that brought up what we needed to do, those solar array installs. Things get really busy when a cargo vehicle shows up. We got a lot of unpacking to do, and there's not a lot of room.
There we go, inside node 2, looking at the hatchway. We can see all 4 of our crew members actually suited up and ready to go.
So this is the middle of March.
All hooks open.
All hooks open to part burn 1.
Duke and crew 5, magnificent sunset departure. You guys look great. Great job up here. We're going to miss you. Godspeed.
Obviously, that beautiful bright light in the middle, that's Crew Dragon Endurance coming home after 157 days in space.
Main chute descent rate nominal.
That's a great sound when those chutes come out.
And as you just saw, splashdown of Crew 5.
Great sound when the Air Force PJs are knocking on the door.
Have been released.
Dragon, brace for capsule lift.
And they put us on a boat, take us out of the spacecraft.
And there it is, side hatch open.
Dragon Endurance, on behalf of SpaceX, welcome home.
So we didn't film that in a basement in Houston. It was just amazing, amazing thing to be a part of. And so that is what we're doing. Right now, we're still sending crews to the space station. We've got, next week, we actually have another spacewalk that's on deck. My friends Laurel and Andy are going to go out the door. This one has got a variety of things that they're going to do. One of those things is they're actually going to swab the exterior of the space station looking for microbial growth, actual fungi or bacteria that are surviving in vacuum. So it's kind of fun to sit in meetings in Houston, and when somebody says, are we looking for aliens? Not really, kind of, maybe, right? These are it's biology that probably came from inside the space station and was expelled through one of our propulsive jets. So they're going to be doing that among a handful of other things on Thursday. And we're also getting ready to launch that vehicle on the left. That is the Boeing Starliner. That's the one I was assigned to for many years. We had some technical trouble, so they moved both Nicole and I over to SpaceX. But it'll be exciting to get 2 different providers here in the U.S. servicing the space station. And the reason we do that, it's called dissimilar redundancy. So we've got 2 different providers. So if there's a problem with one of them, we're not in a position where we can't get back to the space station. Okay, so real quick before I show you this video, this is an old video, but I love it because when I first got to NASA, Nicole was in my class, there were 8 of us. I remember sitting in some meetings and SpaceX was talking about landing the first stage. So when we go to space, we've got 2 stages for the Crew Dragon vehicle. The first stage does the heavy lifting to get you through the atmosphere. We get rid of that first stage, and up until this moment, it would end up in the Atlantic Ocean. SpaceX was talking about how do we save all this expense? How do we recycle our first stage? And the vibe that I felt in human spaceflight was, these people are crazy. There's no way, it cannot be done. The government had better not be having to pay for this. And it's just really cool to sit there and think, well, why can't they do it? What makes it impossible? And they had several failures. They're trying to land it. And then on this vehicle, which was a cargo vehicle launched to the space station. So if you look in the upper right, that's the customer. That's NASA. So the vehicle itself in this picture is at 228 kilometers. But the video is of the first stage coming back down. Should be some audio with this one. I love that one because they did their job, they got the cargo vehicle to the space station, and then they did this other cool thing that has really kind of revolutionized, in my mind, human spaceflight. I mean, we are recycling first stages, and last night I was realizing I'm going to show this video, so I looked it up. As Professor Gertis mentioned, we launched October 5th of 2022, just over a year ago. That first stage has been flown 7 times since then. It's just amazing, and to think of the expense that we're saving, and there are people who say, I think I'd much rather launch on a rocket that's been proven to work as opposed to one that hasn't. So there's different philosophies on this, but that was, in my mind, just a testament to how dynamic and how exciting things are. Yes, in human spaceflight, but really anywhere that we're all trying to solve really hard problems and working together on it. That one just makes me really happy. So what are we doing next? We're going to do that path D on that Newton's cannon slide. We're going to the moon. So when Frank and I had done, let's see, I think it was our first spacewalk, Artemis launched the next day. It launched uncrewed. We really wanted to see it. We also really didn't want to get hit by it. Neither one of those things happened. We weren't on the right side of the planet, so we couldn't see it. But if you saw any of that imagery that came back from Artemis 1, it is just incredible. And so in the next year to year and a half, we're going to be launching our first crew on Artemis 2. And they are going to do the first mission in this generation of going around the moon, and then eventually we're back to the moon to stay. So less like a touch and go like we did in the 60s, and now we're going to be building an entire infrastructure there, including a space station around the moon. It's really fun to think about these things. Sometimes they, to me, seem very distant and maybe a little bit of science fiction. But when I was on Starliner, I was assigned with veteran astronaut Sunny Williams, who's a great friend of mine. And it's really neat. She came to the astronaut office in 1998, and she often tells me about how when she was a young astronaut, there was all this talk and all this planning and all these meetings about this thing that was a space station. And she never thought there'd be any way we were building a space station. And sure enough, here we are. And it has performed beautifully, and we're just doing absolutely amazing things. Okay, so that is my mission. But in a more global sense, I feel really passionate about this. I did high energy physics before the Navy, and then I became a test pilot, and now I do this. Which is to say I have no idea what I want to do when I grow up. But I will tell you, I just have a real passion for exploration's sake. I'm often asked, what are we going to learn specifically? What are we going to get from this experiment, from this mission? And if there's one thing I've learned in science is if you already know what you're going to learn, then there's really no sense in doing it. When some of the fundamental studies that we've done throughout the history of physics have led to some really revolutionary ideas, but that's not the reason we started doing that research. We did that research because we were curious, and that's what it's like to be a human being. And it reminds me of a quote from the first director of Fermilab, Robert Wilson, who was testifying in front of Congress, And one of the congressmen asked him to specifically identify those things about Fermilab, this proposed idea, specific things about Fermilab that would contribute to national security. And Robert Wilson's response says, it has nothing to do directly with defending our country, except to help make it worth defending. And that one has always stuck with me. So, with that, I promised the Michigan Physics Department we would do a demo and a little bit of math. So, one of the questions, and we'll do this and then we'll get into the question and answer if that works for everybody. How are we doing on time? We're doing okay? Well, this will just take a couple minutes. So we work out a ton up there, but our flight docs are super concerned that we're going to lose weight. So I was on a 3,000 calorie a day diet, which I had to quickly get rid of when I got home. But it was really hard. 9 or 10 o'clock at night, I'm trying to jam more food in my mouth. And you know, the doctors would say, it doesn't matter how you get the calories, just get the calories. Which sounds good in theory, but you're on a space station, so you're kind of limited on your sources of those calories. You know, it's a little bit like our kids. We tell them they can go to college wherever they want, as long as it's Michigan. So you're kind of limited on where you can get these calories. So does anyone have any ideas on how we would measure a crew member's weight when they're in space? Yeah. Yeah, well, we will. We'll get into those numbers, and that's the beauty. That's like this code that nobody understands. I could tell you that I weigh 76 kilograms, and nobody knows what that actually means. But yes, we do tend to use the metric system. But you can't really get on a scale in space, right? You're standing and you're floating. So you are weightless because you're in free fall. Did anyone see anything in that video that I might have been doing that might be a way to measure my weight? And while you're thinking about that, I got to tell you, what's that? Yeah, that's one. We used to do that. We don't do that anymore. But the answer was essentially throwing you. There was I think it was called SLAM, and it was this device where you got yourself on it, and it imparted a known force into you. And Newton tells us F equals ma. Force equals mass times the acceleration. Well, if you know the F, and you can measure the A, then you know the M. The M is mass, kilograms, exactly. But we don't, turns out it was really inaccurate. So we do it in a different way, and it's the way we've been doing it for 25 years. And this is one of the things I wanted to show you in the first Saturday Morning Physics, but I couldn't float us back there. But I will first start by telling you, I thought it would be really fun to have a goofy picture for this slide. And so I Googled fat astronauts. And we know this about Google, right? It's a little bit treacherous to do those kind of things. The one thing that I learned two things. One thing is there's a new movie coming out that's called Fat Astronauts. I don't know if it's going to be funny, but I had no idea it was coming out. The second thing is you need to be really careful when you Google, because sometimes it cuts really deep. And I realized that's our crew. So I don't have a funny picture. So here's just working out. So we need to maintain awareness of our body mass, so we know, are we working out too much? I think so, but or are we not working out enough? Are we eating correctly? So the way we do it is, if you saw in that video, there was a point where I was on, looked like a horse, and I was on it, and I was bouncing up and down. Okay, and so what that is, it's just a spring. It's just simple harmonic motion. So this is back in the Russian segment. What I love is it's just so elegant and it's so simple. So if you can kind of picture this being that metal horse that I ended up getting on, the force on this mass is given by the strength of the spring, which is K, and how far it's displaced. And I release it, and it's just going to oscillate like that. It's a simple harmonic motion. Now, if you get on it, so now this is the horse plus Josh. Let's do it like that. It oscillates a lot slower. And it's really cool. Just from simple math, Newton's helping us again today. F equals ma, and the force on it given from the spring is F equals minus kx. Setting those two things equal to each other, I hesitate to say I'm going to spare you the math. I did have the math until like 2 hours ago. It was in there. But then I realized we'd have to kind of rush through it. And for me, math is not something that you are spared. It's really exciting and engaging and elegant. And it's miserable when you can't follow it, right? And you're behind and you never catch up. So suffice it to say, this equation will then tell us what the strength of this spring is. By the way, Newton helps us a third time in getting to this equation. We use calculus, right? That guy was really helpful for this talk. So what this says is the strength of the spring, you can determine it if you measure how long it takes for one of these oscillations to complete, and if you know the mass. And so do you mind, Michael, can we run the calibration video of the mass measurement? So here's that horse. We would just measure the speed, the frequency, how long it takes for that period to complete. That's great. And can you go back now to the PowerPoint, Michael? So by measuring t, and we know because we can measure before we even launch it the mass of that horse, we can determine the strength of that spring. Now, if I get on that horse and I get myself on there, what is the strength of the spring? How much has it changed? It hasn't changed at all. It's the same spring, right? So here's that same equation, but now it's a different period. It takes longer for the oscillations to complete, and there's a different mass. Okay? So simply by measuring that frequency and knowing this first mass, we can determine what m sub j is, the mass of Josh plus the horse. And I'm going to tell you that because the first time I did this math, I'm like, wow, I was overweight. And I'm like, oh, I got to subtract the mass of the horse, right? So for anybody who sees this online, I can tell you right now that this original mass is about 6.8 kilograms. And so with that, you'll quickly learn that my mass, if you play this next video back, actually, Michael, can you show that one of me on there? Turns out my mass was 76 and some change kilograms. Again, nobody knows what that means because it's kilograms, right? But it turns out I was still losing a lot of weight. I ended up, despite eating 3,000 calories a day, I think I ended up losing like 8 to 10 pounds. Anyway, this was a very simple and elegant application of just fundamental physics that I just loved seeing it. And then we float over and get to the Russian screen, and it's both in Russian and in kilograms, so we don't have a prayer to understanding what it says. So if you want to go back to the slides, we'll do this last slide. Thank you, Michael. So the question is, does Saturday Morning Physics need to send more donuts to the ISS? I think we clearly answered yes. Yes, we do, because I was apparently still not getting enough. So with that, we'll go back to, I don't know, best photo I could find. And if you want, I think we're okay on time. Is everybody good with that? We can do some question and answer. Does that work? Okay. Awesome. Thank you. Hey, buddy, I know you've got one. How do you want to do this? We've got questions in seats. Should they get in line?
So I'll take care of it.
Oh.
I'm here.
I'm not in charge.
Josh, thank you.
Thank you.
While we get set up, we're going to have microphones here. And so if you'd like to ask a question, please go into one of the aisles behind a microphone. But on the subject of donuts, I pulled these out of my freezer this morning. They're going to stay in the bag. They've been there for 9 months. But I want you to know that they're very special, sort of freeze-dried. But unlike the ones out there, these are maize and blue.
So. Oh, nice. Nice. Thank you.
So we'll leave that there. You can.
Awesome.
All right. This is great. It looks like we have a number of people ready to ask questions. So we're going to start over here on our right, Josh.
Sounds great.
Did it feel weird coming back to Earth? Like, for example, when gravity came, did it hurt? Did it feel strange? What hardships did you have when you first came back to Earth? Was something hard or something difficult?
So let me start with what it felt like when we got up there. My back was incredibly sore as those muscles start to stretch and the spine starts to straighten out. You're supposed to get taller. I was really excited to be the tallest person in my family. I told my wife, hey, we're going to dinner the first night I'm back so that I'm the tallest person in the family for at least 2 weeks. You usually get about 1 inch to 2 inches. I got nothing. I was battling it out for 4th in my family, but I still had to go through the back pain. When I got back, so I didn't feel sick, but certainly unstable on your feet. I tried really hard to do some vestibular things to minimize that. And I think we effectively did. I was able to walk fairly reliably after 5 or 6 hours. But I think that for me, that was the worst part was, being able to maintain an upright position because your inner ear has been doing something goofy for quite a while.
Hello.
Hi.
Hi, my name is DJ, and I have 2 questions.
Yeah.
One, I hope to become a pilot when I grow up. And do you have any advice on, I don't know exactly how I'm going to get from this point to that point. Do you have any advice of how you figured out what your path was and how you actually got from being a pilot to being an astronaut?
Absolutely. It's TJ, right?
DJ.
TJ or DJ?
DJ.
Delta Juliet. You'll learn that as an aviator. That's how we make sure that we don't get those letters wrong. DJ, thank you so much. I do have some advice, and it's because, I've tried a handful of different things in my life, and I'm going to tell you that every time I go to do something new, it's initially very daunting. I went into physics in college simply because I didn't quite get it in high school, and that frustrated me. So I decided, this is what I'm gonna go after. And I really, of course, love the idea of trying to understand the universe at a fundamental level. But I'm going to tell you, going into something like physics, for somebody who it didn't initially come immediately naturally to, that is really daunting. And it turns out it's often, a lot more daunting when you think about it than when you actually do it. And that goes for physics, aviation, space flight, spacewalks, all of it. You kind of build it up a little bit too much in your head. I mean, you need to respect it, but at the same time, you don't need to overdo it. And then secondly, it often is just another language. When you go to take your first flight, I assume you'll be a lot like me, and you'll hear all the comms. You'll hear all the communications, talking to air traffic controllers, talking to other pilots, and you know that it's English. Because it legally has to be English, which is whole nother conversation. But you know that it's English, but you can't understand what they're possibly trying to say. And it turns out, once you've done it long enough, you realize, oh, this is just the new language. It's just like Russian. It's just like math. In physics, that language happens to be math. And once you speak that language, oh my gosh, it is exciting. It's not that it's super easy, but it's now something you can grasp and something you can really get passionate about and enjoy. So it doesn't have to be as scary as you make things out to be in your head. And I mean that, I'm saying that from a personal perspective. I actually call it academic courage. I came up with this term. I went to a small liberal arts school. So in addition to physics and math, I did a lot of other studies as well. And it turns out that if you just have the courage to go try something, it's really not going to be as daunting as you think.
I also have a question about what's it like to see the Earth in relation to the whole universe and just feel like you could actually reach out and touch the only home that humans or even known life has ever known.
Yeah, it is. It's overwhelming, and we're not even that far removed from Michigan here, right? When we're in low Earth orbit, but the view is incredible. The stars, they don't twinkle because they're not really coming through the atmosphere, right? They're just steady, gorgeous, beautiful points of light, and it is remarkable to try to put that whole experience in context, and you realize very quickly that we are so incredibly lucky to have won the universe's lottery. I mean, this planet is unbelievably perfect in every sense of the word, and we need to protect it. And I think for me, at least, that was the overwhelming sense of, I just wish that everybody could experience this perspective, and then maybe we don't argue about things that really don't matter and things that we've made up. We can just realize how lucky we all are together to be here. And so for me, that was the take home for me. And I love space. It was incredible. But this is where I belong. This is where I evolved to be.
So I'm going to bring one of the online questions here.
Yeah.
Because it's from Ian, who's 3 years old.
Oh, great. This is going to be a hard one, I guarantee it.
He says, where do you store things in space? And he keeps his dinosaur toys in cages.
In cages. Yep. So, Ian, you're absolutely right. You can't just let things float. You're working with tools, and you'll put one with a little bit of Velcro, you put it in a spot, and then it will very maliciously start floating away. And you might lose it for up to a week or two. It's pretty frustrating. I remember calling my family at one point, about 4 months into it, and I said, man, I am just so sick of everything floating. And my kids said, Dad, you're in space. And I said, I'm happy to be floating. I just don't need everything else to be floating because it's really hard to maintain things. And so we put them in bags, and we attach those bags to different places in the space station, whether it's behind panels or it's on the front of panels. Storage is at a premium in the space station. And in fact, my first reaction when I came into the space station, that video you saw of us floating in, my first thought was, holy cow, this place is a mess. Because it's not at all like the mock-ups that we have in Houston, because we have to store things everywhere, and it just looks like chaos. The ground knows exactly which tool is in which bag, which is located in which spot, but it is really overwhelming. And for me, I didn't really appreciate it until I got back, that I'm very Euclidean. I really like right angles. Like, there's a lot of right angles in this room, and I love it. And it turns out in the space station, you don't get that. It's all round, and there's bags and computers and cables and plumbing, and so getting to see right angles is super refreshing to me. But to Ian's question, yeah, we have to store everything in bags. It's going to try to get away, and it eventually still does.
Chang Ming Fan, UN alumni. My questions are childish. First question, did you see UFO over there?
Did I
Second
see
question.
UFO? I can't tell you.
I have second question, also childish. Did you see any man-made objects or buildings about half mile, 1 mile high on the surface of the Earth on a clear day? No, on the clear area on this planet.
So the question it was, one, did I see UFOs? I'm going to skip that one. We did actually see the Chinese space station when we were up there. We just saw it. It was a really bright light. So we were able to see that there were other people in space while we were out there. In terms of what we were able to see on the Earth, yeah, you can make things out. It's really hard with your naked eye. Certainly at night, you can. The planet is alive. You can just see all the different cities, and you can see that there's humanity doing their thing down there. But we have some really great cameras where we can, if we want to, zoom in and see things like the big house. But using your naked eye sometimes is a bit of a struggle during the day. But you can see cities for sure. Individual objects are a little harder.
Hi, my name is Emily, and I have a question. How long would it take to fully set up the space station on the moon?
Oh, it was Emily? Is that what you said?
Yeah.
Emily, we're hoping to be back to the moon in the 2030s, right? There's a lot of problems that need to get solved between here and there. But you don't want to rush these things, but you do need to get it done because the longer you're doing it, the more expensive it is. But that's our goal, is to be returning to deep space in the, before you're probably in your 20s.
Thank you.
Mm-hmm.
Over here, Josh.
Chris Winkler, retired U of M research scientist. I can't help this. I should apologize ahead of time, but I'm an engineer. Your mass measurement technique is very interesting. Those nice little simple equations depend on the fact that m sub 0 and m sub j are rigid bodies. And I think m sub j is not so rigid. There may be things moving around inside your abdomen and so forth.
That's right.
That strikes me that the technique might measure a little low, so maybe you didn't lose 10 pounds.
Well, Chris, you're exactly right. First of all, I think I got the number wrong. I think I measured like just shy of 74. I think it was 76 and some change before we went. But you're right. The Russian trainers make a huge deal of making sure that we get as small of a body as we can and do not move around. But you're right, there's going to be limitations for sure. And I haven't gotten into their algorithm. I don't know if they have a correction factor. Maybe they do. Maybe there's a kind of an offset that is typically used for a human body. But we do it in the morning, so there isn't too much. We're not allowed to eat, so there's at least not that kind of stuff sloshing around.
We call it a spherical astronaut problem.
There we go, exactly. I got sent a homework problem after the last Saturday morning physics. And I remember, I think you said it on like a Monday or Tuesday. I'm like, wow, I got a long day today, or tomorrow, but I'm going to stay up and do homework. And so there were spherical astronauts, as was the approximation that was used.
Hi, my name is Trevor. I have two questions. How long did it take to adjust to like walking around after you got back from the space station?
So for me, I was able to be, on my own. I don't know, the doctors were really happy with that, but I was okay after about 6 hours or so. There's still people around you trying to make sure that you don't fall. But that can take several days. We tend to not drive for at least a week, if not 2, but your doctor will sign you off on that. I broke out of Houston as soon as I could, and I went skiing up at Highlands, up in northern Michigan. Houston didn't know about that until just now, but I just told them. But that was really fun. So it varies from person to person, just as how you feel when you get on board. That varies from person to person, and in fact, it varies within a person. Sometimes a person will go up for one flight and they'll feel great when they first get there, and the next time they go up, they don't feel good at all. And so it takes a little bit of getting used to both being in space and being back on Earth.
Also, when you guys had free time, what did you mostly spend your time doing up there?
So you can do a lot of fun things, right? That cupola is really a tough one to pass up. But you're able to make calls if you want to talk to your family. We would actually stretch a screen over the hatchway to the airlock, and then we would float a projector, and we could watch. We watched Michigan football. In fact, it was during the Illinois game, and there was this LOS. It's a loss of signal. We were in between satellites, and so that was the longest 20 minutes of my life because Jake Moody hadn't kicked his field goal yet, and I didn't know how this was going to turn out. It seemed really bad. You can't really pace in space, but that's effectively what I was doing for about 20 minutes. So we can watch things like football if we've got satellite coverage. So we've got email. We can watch movies. There's a ton of movies up there. So sometimes we'll get together as a crew and use that same screen to watch movies.
Hi, I'm Kieran Garcia. I'm 11, and my question was, what was one thing that you kind of remembered that you could no longer do because you were back on Earth instead of the space station?
So one thing that I learned when I was in space, and then I tried to do down here that didn't work. There are stories of this. There's a friend of mine who met the vice president, and he had his arm around his 12-year-old daughter. He had his favorite drink, a Diet Coke, in his hand. And he went to meet the vice president and let go of the Coke, dropped it on the vice president's shoe, and then shook his hand. Love that story. I did not do that, but I didn't meet the vice president either. So for me, I don't know. Here's one. It wasn't really so much something that I learned, but sleeping in space, right? This was one of the things that concerned me. I thought, man, I'm not sure how I'm going to sleep. We all have essentially a closet that we sleep in. Mine happened to be on the deck, on the floor of the space station. But that really doesn't matter, right? We can flip the space station, and now the deck is the ceiling. And you go in there, and now, once you close that door, there's no reference for what's up, what's down. So in my mind, I was sitting up or floating up. And so we put our sleeping bag, we strap it to the wall. It's got sleeveless, it's got holes, so it's like a tank top if you want it. And you can take your arms and you can just let them float out. And you can, what I would do is I pull my hands in, and it ended up being so comfortable because there's no pressure points on you at all. And then I came back, and my first night of sleeping, about an hour into it, I was in so much pain because of the pressure on my ear. I had turned my head just a little bit, and I was so not used to that pressure of anything pushing on my ear. Now, I will tell you one of my favorite things to do when we were in there. And so I like to meditate for 10 or 15 minutes before I go to sleep. And, you know, this happened to both me and Nicole separately. It was so funny to have this conversation over breakfast. We weren't even using the same meditation app. But you're in there, and you're listening, and the voice says, relax. Imagine you're floating in space. Well, I can't relax now. I'm super excited. I need to call you and tell you what just happened. So it happened to both of us. So probably the ear.
Just to maybe follow that up, there's a few questions that came online about spacewalk.
Yeah.
Yeah, and I'll just summarize them. Is there anything that you do on Earth that's quite like it? And it's probably not like walking at all. Is there a better name for it?
There certainly is a better name for it. I don't know if I know what it is, but it isn't walking. In fact, your legs tend to be a problem. They're just getting in the way. They worked out pretty well for me because I was plugged into what we call a foot restraint at the end of that robotic arm. And, you know, the problem is you can't see your feet when you get into that because this big spacesuit's in the way. So you're doing it all from feel through a spacesuit. So you put your foot into just a kind of a bar that goes over the top, and then you push your heel in and then out, and the spacesuit doesn't want you to do that, so it's a lot of work. And then you get yourself convinced that you're in. I don't have much of an ego, so I would quickly turn to Frank and say, I'm pretty certain I'm in. Am I in? Because I don't want to learn that the hard way, as that arm is moving me around with 750 pounds of mass, and then stops, and then I go shooting out of the foot restraint and do a spectacular end to a Hollywood movie. So it is not a walk. You're translating with your hands. You try really hard to not. I told myself for the first hour of the first spacewalk, do not squeeze. Right? You don't need to squeeze. You need very little pressure to keep yourself in place. But then you're also in the first hour of your first spacewalk, and there's a planet below you, and you're trying not to fall off. Right? So you can get yourself really exhausted. Astronauts have to work forearms quite a bit because the spacesuit itself is pressurized. And so every time you do this, it's like squeezing a tennis ball. So at the end of a day, you know, you're in that suit for probably 12 or 13 hours. So at the end of that day, it's pretty exhausting. So what prepares you for it? We actually practice spacewalks in a giant pool in Houston. We have a mock-up at the space station. It turns out that pool's not even big enough for the space station, so we have to pretend, okay, this piece is actually connected to this piece in real life, but we have to put it here. And so we translate there with our hands. We've got divers who tweak the weights on our bodies to make sure that we stay neutrally buoyant. We don't float, we don't sink. We call it the NBL, the Neutral Buoyancy Lab. One of the limitations, though, to that is if I'm moving something really massive like that IROSA, that solar array, if I'm moving that in the pool, it takes a lot to get it going, and then when I need to stop it, it stops on a dime because of all the water resistance. If I do that in space, I'm going to send myself into a retrograde orbit, and I'm going to go shooting off of the space station. So there are some limitations to the training. I will say the one thing that I think prepares you the best for this, and I would have never believed this before I was at NASA, is aviation, like DJ was mentioning. Everything we do in our training, whether it's robotics, spacewalks training, emergencies in the space station, all of that is pretend. It's all made up. And if you mess something up, if you fall off the space station in the pool, everybody stops. Okay, let's make sure that never happens in real life. We can debrief anything, right? So we're able to get better in our training because we're pretending. In aviation, it's the one thing where you're not pretending. And so that heightened sense of, I can't mess this up because my butt's on the line and my buddy's butt is on the line. So that operational sense coupled with the training, I think, is probably the best way to answer how we get ready. First of all, love the shirt. That is an awesome shirt.
My name is Max, and how did you become an astronaut?
Hi, Max. Well, I'm pretty sure it was a clerical error, but they can't take it back now. So there's nothing they can do. I'll be honest. I did several things in my life, and I hope to continue doing things in my life that I just happen to be passionate about, things that I love. I did physics because I was really, really interested in it. I was interested in aviation, so I went and did that. I actually, with a friend of mine here locally, we started a company just because we thought it would be really cool to do it. So I noticed that in our class that was selected 10 years ago now, there were 8 of us in that class. And the cool thing about that is that all of us happened to be doing things in our lives where when we got that phone call, we thought, oh, I know I'm going to say yes, but I'm really excited about what I'm doing right now. So I think the theme is that people are doing the things that they're passionate about, and if they happen to be a good fit for NASA and to be an astronaut, then more power to you. I will tell you, I was actually here on campus when I got that call. I had just put my name in at Supercuts, and I was going to get my hair cut. I had just started a process at LNF. I don't know, is Catherine still here? My friend Catherine, who was helping me out. So it was going to take a while, so I went to put my name on the list at Supercuts. And right as I gave her my name, my phone rang, and it was a 281 area code, which is Houston. And I said, oh, I need to take this. And she said, you need to be back in 5 minutes. You can't be late. And I said, I'm pretty sure this is going to be a short phone call. I'll be back. It'll be fine. And I remember Janet Cavandi, Director of Flight Crew Operations, said, how would you like to come down to Houston and be an astronaut? And she told me later that my response was, oh, crap. And she said, excuse me? And the reason I said, oh, crap, is because when I was dating my wife, whatever it was, 15, 20 years prior to that, she said that if I had ever dragged her to Houston, she gets a pool. And I thought that was a fair trade. But then when Janet asked me if I wanted the job, I realized I couldn't afford a pool. So when I told Janet I couldn't afford a pool, she said, I don't know what you're talking about. Do you want to be an astronaut or not? Long answer, do what you love. You can't lose. Does that work, Max? Okay.
Thank you very much for sharing your experience. My question is, what was your kids' and your wife's reaction when they learned you were going to space? And in other words, how do you, as a human being, react when one of your closest relatives actually go to the International Space Station?
Say the last part again. How do you
react as a human being when one of your closest relatives, so you, goes to space or the International Space Station?
Right. Yeah, we do. We ask a lot of our families, and we often don't even realize we're doing that. So for my family, when they found out that I was launching on Crew 5, ours was a unique situation in that I was flying to space in the next year, that had been a true statement, or we thought it was a true statement, for probably about 5 or 6 years, because I was assigned to this different spacecraft that I was a test pilot on, and we were trying to get it. So my family was already in this heightened state for several years. So I think at some level, when they heard we had an actual date and I was launching, I think their reaction was probably, finally, we can stop talking about this. Yeah, it is. Sometimes when getting things ready for work and I'm trying to make sure everything's together, there's a lot of energy in the house, and I learned that my family, at least my youngest son and my wife, they often have this joke that when I walk out the door, they both go, and they just sigh, because now all that chaos is left with me. And apparently, as the rocket left the launch pad, Graham turns to my wife to make a joke and goes, but yeah, it is. We prepare them for things potentially going sideways. But I'll tell you what, the people who make it happen make sure that we don't cut a single corner. There's always going to be risk in this job. There's always going to be risk in life, right? And so if you're trying to eliminate risk, then if you drive it down to zero, then you're just not living. So we work really hard to make sure we're not taking any unnecessary risk. But yeah, you do have to have some harder conversations to make sure that everybody's on board. You don't want to force anybody into this situation. But they were excited. They were very supportive.
Hi, my name is Valentina. I was wondering, what's the process for deciding which experiments to do on the ISS?
So, it's an incredible question. We are not part of that. We are told what to do and when to do it, right? Which is kind of hard when you've got a science background. You very much want to be involved at least in one of them and have it be your own. You do find yourself gravitating to certain ones, and you establish a relationship with the researchers. But in terms of determining which make it to the space station, there's an entire board that evaluates the proposals and is really encouraging and supportive because this is an asset that a lot of researchers don't even realize that they have available to them. So it tends to be something that we work really hard with the researchers to not only get them up there to make sure that they're capitalizing on the opportunity that they've got. So it's a whole bureaucracy applying and pitching your idea.
Thank you.
Mm-hmm.
My name is Genevieve, and I was wondering, when you were in middle school and early high school, were you like some sort of like star student going ahead of everyone in like math and science, or were you kind of like average?
Genevieve, I am still average, for sure. So in junior high and high school, academically I did well, but like we talked about earlier, it wasn't because it was just so easy. I just really enjoy working. I get a lot of satisfaction out of that. I like to work hard. And so I think that's how I was successful in junior high and high school. I will tell you, though, when I was in 7th grade, we had to take a test to find out if we were going to be in advanced math. And because I had worked pretty hard, but I don't think I was working really hard by 7th grade. Things had come pretty easy. So we went to take this test, and I did just okay. And I remember that my 7th grade math teacher, and that was, I think it was like June, to find out if I'd be in advanced math for the fall. And she came to me and she said, I know that you can do a lot better on this test. And so 2 weeks later, I took the test again, did much better, was in advanced math. That allowed me to get to calculus while I was in high school, which allowed me to it's really the tool you need to do physics in college, which allowed me to get my Ph.D., which allowed me then to become a test pilot. So that test in 7th grade and that teacher who suggested, hey, why don't we have you try this test again, was a critical moment in my life, and that's why I invited her down to my launch. And so she was there at my launch.
Hi,
Hi, Dr. Cassada. My name is Shivana. I was just wondering, can you recall what sparked your interest in astronomy or aviation?
What sparked my interest in aviation?
Or astronomy too, whichever one.
Or the shuttle program, is that what you said?
Astronomy or aviation?
Astronomy or aviation. Yeah. So growing up, my real passion was baseball. I really wanted to play Major League Baseball. But we learned pretty quickly that my fastball was never going to break 80 miles an hour. So I needed to find something else. And it was around that 7th grade time frame when I was just loving math and loving science. And I always had an interest in aviation. And I thought, wow, if I just keep doing the things that are interesting to me, I'm going to have a life of satisfaction, at least. This was a job that I'd always been interested in because it merged those things. It merged math and science and aviation. But at no point did I ever really count on it. It's a little bit like playing the lottery. You can't win if you don't buy a ticket, but you better have a different retirement plan, right? So that's how I view it. But yeah, it just happened to be things that I was just loving at the time, educationally.
Okay, awesome. Thank you.
I think we're going to be able to get to all the questions, but sure. I just want everybody to know, if you stick around, you'll have an opportunity to get in a group photo with Josh at the end. So
sounds great.
Don't leave.
My name is Oscar, and my question is, how did it feel when you went up into the space station and...
When I first got there, Oscar?
Yeah.
When I first came in. Well, I'll tell you, and I actually told the group this yesterday, I don't mind telling you that on the way uphill, we call uphill the launch part, right? I was feeling just fine in the Crew Dragon. We had some different tests that we needed to do in there, some hardware evaluations. But I knew that when you get into the space station, it's so voluminous that it can be really disorienting. So I didn't want to do anything right away, that was super provocative. I didn't want to start doing flips or anything like that. So when I got in there, in addition to thinking it was messy, I just thought I wouldn't do anything too crazy. And so after probably 5 or 6 hours, I wasn't feeling great. The body's been through a lot, and we haven't slept much. Life is kind of crazy when you launch to space, and so I wasn't feeling very good. And my friend Chell, who's a medical doctor, he was up there for a week while we overlapped for that week, and he floats over to me and he says, "Hey, do you want a shot of Phenergan? Phenergan is an anti-nausea drug. It keeps you from feeling sick." And I said, "Boy, I don't know, Chell. What do you think?" He said, "If I felt like you're feeling, I'd take the shot." I said, "All right, Chell, here's my butt." And I just floated up. He sticks me in the butt, and I slept for 12 to 14 hours. I felt great. So wasn't feeling great a couple hours after I got up there, but some people go through that. Some people don't. Some people feel bad when they get back. Some people don't. There's really just no telling.
Hello.
Hi.
My name is Andrew. I just wanted to ask about the sun's radiation, of how, especially the spacesuits, of how, if you know the engineering and physics behind how you block it.
Yeah, so that is one of our bigger threats going to deep space. So NASA tracks the radiation that we're exposed to. They track it not just during our mission in space, but they're tracking it prior to launch, when we're flying. So they keep a really good tally on how much radiation we've been exposed to. I'm going to be honest, there's not a lot of shielding that we have on the space station. It'd be great to have, big lead barriers that are protecting us. And there are different spots in the space station that do better than others. You can imagine, if you're on one side of the space station and you're sleeping there, that one maybe is getting more radiation than another. So they're monitoring all of this. But that is one thing that we don't have. We don't have bags of water that we sleep surrounded by. These are all the kinds of things that we absolutely need to solve before we go to deep space, where the radiation is really, really going to be a problem. But they monitor it, and in fact, they will restrict your flying in space if you need to. They'll say, nope, you've had too much, you're not going, or you're at least not going for this many years.
All right, thank you.
Hello, Josh.
Hello.
Let me just say, first of all, you said you were, quote unquote, still average, and let me tell you, there's nothing average about what you did up there. So I just want to say that it was a beautiful presentation. I got two questions, and I'll promise I'll try to be quick. The first one is, what was your worst moment in space? Like the moment you just felt like pure fear, you just missed your family so much, you were just so overwhelmed because you were so alone. I want to know that.
Okay, so first of all, I hear you on the not being average thing. I understand the perspective because I'm there myself. When I see resumes of other people, things that they've accomplished, I'm in the same boat where I think, man, that is incredible. That person is just operating on a much different level than I do. So I guess I'm thinking this is probably fairly common to people who are not egomaniacs, I guess, right? And I think this gets back to was it DJ's question about this idea of academic courage, right? This idea that, man, it just is so much more daunting until you've done it. And so the things that I've done, if you haven't had a chance to experience them, they probably seem just something that you can't even imagine. But in fact, I'm a pretty average guy who likes to work hard, and I try to capitalize on my strengths and try to minimize the impact of my weaknesses. So I don't want to spend too much time other than, we're all remarkable in our own way, and that's the only way we get any of this done. I didn't fly to space by myself, right? I just happened to be the person who got put in that position because of all the people in my past who have enabled me to do it, from 7th grade math teachers to advisors to friends, right, and colleagues who I went through test pilot school, people that I've worked with, just people who've just been supportive, right? I didn't do any of that on my own. Being afraid. Oh, yeah, absolutely. First spacewalk. We had to go to the far end of the space station, and I needed to go. Do you remember in the video, I pop off that thing, it was really hard to get off, and my friend Zena says, she was so supportive, just such a great voice to hear when you're out in space. She's excited, woohoo, we got it off. To get to that thing, that was terrifying. So I remember a moment where, again, first time out the door, and I'm at the far end of the space station, but what I need to do is get all the way out to this round canister that is holding the solar array, and I need to swing myself around, and now I'm going to be the person furthest from humanity than any of the other 7 billion people, right? And I'm thinking, man, okay, we're all right. And I look at the path to go, and usually there are these yellow handrails that you can grab and translate on, and they're really comfortable. You can get your glove all the way around it. But in this case, there were these struts, and they're silver metal round struts that are pretty big around, so I can't even grab onto it with one hand. And I need to go all the way there, not slide off, and then get over to this canister. And I remember a moment in my brain when I said, yeah, no, we're not doing this. Nope. And it's just a moment, but my brain's saying, this is stupid. We are not doing this. But then you realize pretty quickly, okay, well, I'm not getting back in if I don't do it, so I'm going to have to do this. And, you fall back on your training. But yeah, that was the moment where I'm like, I don't like this one bit.
My second question is, if you ever got drunk in space, and if so, how was it?
Right. Well, you're in space, so you're flying. So drinking is not an option, right? Like when I fly a T-38, there's no going to a baseball game, grabbing a beer, and then flying home, right? So the nice thing is there's no need for it because you're constantly on. You have to be ready for any emergency, whether that be a fire or a depress. The space station can spring a leak. The other thing that can be a problem for us is that ammonia leaks into the space station, and that'll kill you. So at any moment, you end up you have to be ready. And so I think that's also another reason why we burn so many calories. I was talking to a flight surgeon about that. He said, don't forget, your brain is constantly on. You might be meditating and going to sleep, but you also know that you're in space and you're kind of right on, the razor's edge of having to do something really quickly. So, yeah, I didn't have any wine until I got home with my wife, and then we made up for it.
I'm sure it was. Thank you very much.
Yeah.
Hello, my name is Purva. A couple questions. So one thing I've been curious about is does sound sound the same in space as it does on Earth?
So inside the space station, for sure, right? Because it's very much what we're feeling right now. We actually pressurize the space station with air, and we, in fact, it's what we're experiencing now. It's not even like you are, at 20,000 feet in an aircraft. So yes, sound will be transmitted in much exactly the same way within the space station. Outside the space station, yeah, that's different, right? Because now you are in the vacuum of space, and the things you hear tend to be transmitted through your suit, is the way I was interpreting it, right? You hear things like you just made that sound, and it got transmitted inside your suit, which is also pressurized.
It's pretty cool.
Yep.
The other thing is that earlier you mentioned that when you came back to Earth, you saw a lot more 90-degree angles.
Mm-hmm.
And so that means that inside the space station, is there a reason why there's not that many 90-degree angles?
It's because of the stowage, because we have stuff everywhere. Yeah, the modules themselves are round, but we put things in there that would square off the center. So we've got racks that fit in. So they're kind of curved on one side, flat on the other. So there are flat surfaces, but those tend to be covered with, there's stuff that's exposed for sure, but there are just bags and storage everywhere and cables. So that's the part that kind of hides those 90-degree angles from your brain.
Thank you.
Mm-hmm.
This would be really cool to tell my physics teacher when I get back on Monday.
Thank you.
There's several people online are dying to know. You're like a family up there.
Yeah.
And are you like a real family? That is to say, people want to know, are there tensions, et cetera, that crop up?
Sure. So, yeah, you'd be lying to think that you could live with 7 people for essentially a hockey season and not have somebody get on somebody else's nerves. So we actually train for that. We do things, are you familiar with NOLS, the National Outdoor Leadership School? So we will go out as a crew, and really you're just finding yourself in an uncomfortable environment. People enjoy camping, but I like to think of it as type 2 fun. Are you guys familiar with the types of fun? Type 1 fun is something that's fun when you do it. Type 2 fun is something that's fun after you do it. Type 3 fun is never fun, right? So you're in this environment, you're uncomfortable, and eventually after a couple days, people are tired, and they're cold, and they're wet, and that's when you really kind of understand what really is something that's triggering for somebody, what's triggering for you, and you get to the point where you know each other well enough, sometimes even better than your family. You can have a very frank conversation that you might not feel really comfortable doing at home, but you can just say, hey, you got to knock this off, right? And I think that training is invaluable. And that is a problem sometimes when crews change at the last minute due to whatever reason, whether it's a launch schedule, whatever it is. And you can imagine without that foundation, you kind of have to learn it on the fly. So yeah, you do find yourself, and it feels really good actually, because you're like, I'm really mad about this. And then you have this really frank conversation, and then everyone's like, oh, that works. No, everything's good. Now I've expressed to you, you've expressed to me, and now we move on and get our job done.
A couple more questions over here. On the right? All right.
Wait, go ahead. That's me. Okay. So, first of all, thanks for the talk. I have 2 questions, a light question and a heavy question. Which one do you want first?
Let's go heavy. Let's end with dessert.
Right.
Okay.
So how worried are you about the future of international space collaboration?
Right.
Especially with the recent invasion of Ukraine and other rising militarism tensions. Do you have any fears about how that will impact future missions? Whether countries are going to do things on their own way, or do you think that there's some path forward for international collaboration?
Right. Well, I appreciate the question because it's a natural question, and we all think about it. We're all members of society. I will tell you, it is an issue for people above us, right? For us, it's not a problem because, Anya Kikina, she launched with us from Florida. And then my buddy Frank, who is a NASA astronaut, an Army colonel, he launched from Russia with Sergei and Dmitry. On board, the 7 of us, we're that family. We're just good friends. Turns out that was just not a thing. We're not going to solve that problem. We didn't engage on it. But it's a group of people who are doing the same thing. I'm putting my life in Anya's hands. She's putting her life in mine. And we trust each other implicitly. And we genuinely enjoy the time that we get to spend together as individuals. Now, above our level, at the highest levels of geopolitics, for sure, these are hard problems that they need to focus on and get a sensible solution to. I will tell you that from a technical side, the International Space Station, for it to continue to survive, has to have both Russian input and the U.S. input. And the reason is we have these giant gyros that maintain the station's attitude. The attitude is really important so we can point the space station where it needs to be in terms of generating power in those solar arrays, pointing towards the satellites that we need in order to maintain both the communications and the control of the space station from places like Houston. So we have these giant gyros. And so we use conservation of angular momentum to maintain that attitude of the space station. But there's a point at which we call these gyros, we say that they're saturated. They're not doing any more good for us. So what we need is the hand of God to come out and hold the space station right where it is, and then we move those gyros back to their original position, release the hand of God, and now we use those gyros again to maintain the attitude. That hand of God is the Russian segment and the propulsive jets that they have. So this was designed into the International Space Station, that we are going to have to transcend any kind of political issues in order for both nations to maintain a presence in space. So it works out pretty doggone well from our side, but yeah, there's some major questions for other people to work through.
All right, fun question. What was your favorite physics class?
Favorite physics class? Holy smokes. That is really hard for me. I took, when I was a freshman, my freshman year, I took physics for poets because the majors hadn't started yet. They're kind of waiting on, everyone to get caught up in calculus. So then the spring semester was when you did your Halliday and Resnick. Remember Halliday and Resnick? So physics for poets, I loved it because I'm in a room full of people who aren't necessarily physics majors, and we're working through some really cool problems like, can we really travel to Alpha Centauri? What would it require to do that? So that was fun from a non-technical side. From a technical side, I really enjoyed quantum mechanics. Just because it is just such an esoteric and cool discipline, and then to learn that there are different places on the planet that learn it the other way around. We learn Newtonian mechanics and then say, well, that's actually not the case. It works this way in quantum mechanics. But my understanding is there's some people in Europe who they grow up with quantum mechanics and they go, and as an approximation, here's Newtonian mechanics, and see, that's how you get to space.
All right, thank you.
My name is Achama, and I have 2 questions.
Yeah.
My first question is, how does, the spacecraft smell like?
What does it smell like? 25 years of people not showering. It's actually not so bad. We work really hard to keep it clean. On the weekends, we spend several hours. Everyone gets a couple modules, and you just spend a bunch of time in there keeping it clean. There are some modules that smell worse than others. You can probably imagine which modules those might be. We try to keep it all in one module. We tend to work out in one, which is where, at least where Frank and I would shower. But it was really cold in that place. Frank and I used to call it the meat locker because it was so cold. But that's also where the toilet is. So we try to keep all that in one spot, and then the lab is not so Stinky. Did you have another one?
Well, how does the spacecraft work?
Yeah. So we don't need to be firing any jets to stay in orbit, right? We're letting the spacecraft fall towards the planet. Okay, so it's just constantly falling. Have you ever been on one of those rides where there's the Tower of Terror? Do you know this one? I hated that one. My gosh. My family loves it. I cannot stand it. But you're in free fall, right? That is what you're doing in the space station. So that makes it really easy to keep the space station at least in orbit. Now we have to do things like use electrical power to turn on the lights, to run all the experiments, to maintain the attitude, like the way the space station is pointing. So that's how the space station essentially works, is we charge batteries off of the sun, and then we use those batteries when we can't see the sun.
Okay.
Does that answer your question?
Yes.
Okay.
Thank you.
No problem. Thank you.
You know, I think we have time for one more question in this session, and then maybe you'll stick around a little bit. I know we have this photo that we planned.
Sounds great.
Okay.
Hi, my name is Deborah. We've talked about the technical and the social aspects of your experience, but I'm curious about the spiritual experience.
So it has a different effect on just about everyone. My perspective is, it seems like when people go to space, what they experience kind of is just a reinforcement of what they left with, if that makes sense. So religious crew members tend to have a very spiritual and religious experience, and it just reaffirms and is really comforting to see the universe through that lens. And those who are not so religious, but have an understanding of the universe and the way it works, and they have their model on how things have progressed since the beginning of time. It again just reaffirms what they actually went up there with. I think people end up just becoming more passionate about the way they view our planet and our spot in the universe.
Thank you.
That's awesome. And on that note, let's thank Josh again for just wonderful, and what a privilege it was to have you here in person back on Earth. You're such a down-to-earth person, Josh.
It has certainly been my privilege. Thank you so much. I know, what time is the game today? You guys, Okay, you guys have plenty of time. Okay. But I know that helped with attendance because nobody's in Minneapolis today. But thank you so much for coming out. It was really, really fun to share this with you. Thank you.
Thank you. I'm sorry about that last.